So friends, next distillation technique is destructive distillation, and it is carried out in absence of air. Now this technique is largely done to extract oil from woods or resins of the plants that belong mainly to Pinaceae or Cupressaceae family. The wood or the resin, which when it is heated in absence of air, it causes their decomposition, and therefore it is also known as destructive distillation. And this decomposition also releases number of volatile compounds from the raw material, and these released volatile matter is then condensed, and the condensed material can be separated into two layers: an aqueous layer which contains wood naphtha, methyl alcohol and other pyroligneous acid, and a tarry liquid in the form of pine tar or Jupiter tar or other tar, depending upon the type of the wood that is being used. So this is about the destructive distillation. Next type of distillation is the vacuum distillation. Again, as the name indicates, vacuum distillation, this process occurs again in the absence of air and under vacuum. The major advantage of vacuum distillation is we can extract out oils which are having high boiling point constituents at a lower temperature, because vacuum will help in reducing the boiling point and one can extract out the higher boiling point constituent, thereby retaining the original chemistry of the oil. This technique also helps in preventing the thermal degradation of the constituents and improves the overall yield as well as the quality of the oil. Now we move on to the parameters that can affect the quality and yield of the oil during distillation process. And the first and the foremost factor is the mode of the distillation or the type of the distillation that is being used to extract out the constituent or the volatile oil. Say for example, if we have to extract out the oil from a plant material that has high water soluble constituent. So if we use simple water distillation process to extract out those volatile oil having high water soluble constituent, then we will be losing large amount of those constituent which eventually change the natural chemistry of the oil, which will lead to the change in the color as well as odor of the oil. So mode of distillation is very important when we talk about the quality as well as the yield of the oil. Second is the design of the equipment. What is the dimension of the still? What is the location of the condenser? Whether the level of the condenser is lower in comparison to the extraction still or the distillation still, or the level of the condenser is above the distillation still. The collection vessel, location of the collection vessel, whether it is above the level of the distillation still or it is at the same level of the distillation still, all these factors will affect the overall yield of the oil, because we know that the warm air, it moves in the upward direction. So if we place the condenser or the collection vessel at the same level as that of the distillation still, we are not able to condense the vapors effectively. That will affect the original quality of the oil. Next factor is the fabrication of the material. Whatever material we are using to manufacture the distillation units should not react with the constituents of the oil, and this becomes more critical when we talk about expensive oils like rose oil is there, sandalwood oil is there, or kevada oil is there, which have high commercial value. Condition of the raw material also affects the yield of the oil, and it has been observed that size reduction of the raw material always improve the yield of the oil. Crushing of the material, powdering of the material, chopping of the raw material eventually helps in the size reduction. Size reduction helps in better packing, uniform packing of the raw material into the distillation still, which eventually increases the yield of the oil. Distillation time also affects the quality as well as the yield of the oil. If a plant material contains high boiling point fractions, due to which the aroma of that oil is there, longer distillation time is required, and if we expose such material to shorter distillation time, we will lose considerable amount of those constituents, high boiling constituents, which are responsible for the aroma of that oil. Eventually the quality of oil will decrease. Likewise, if an oil is having low boiling point constituents, and if we are exposing that raw material for longer duration of distillation time, then obviously the constituents will undergo a thermal degradation process that will again affect the quality of the oil. So distillation time is again an important factor. Loading of the raw material and steam distribution during the distillation. Now, when we talk about loading of the raw material, it means the packing of the raw material into the distillation still. If there is a non-uniform packing of the material, it leads to the formation of certain steam channels in the raw material, and the steam directly passes through those channels without evaporating the oil from the raw material. If we further overload the distillation still with raw material, then certain rat holes are left in during the packing, and these rat holes will not allow the steam to enter into those holes, which will lead to the incomplete distillation of the oil. Therefore, uniform and appropriate amount of the raw material should be packed in the distillation still. The mesh where the raw material is placed in a distillation still, the pore size of the mesh should be appropriate. If the pore size of the mesh is larger than the particle size of the raw material, then obviously all the particles of the raw material will pass through the mesh and enter into the either water or at the base of the still. So the pore size of the mesh should be properly considered while selecting the raw material or the particle size of the raw material. There are certain operating parameters that can also affect the quality as well as yield of the oil. That is, one is the pressure of the steam. As I told you, if you want to fasten up the distillation process, you can go for the elevated steam pressure, but up to a certain level. High pressure steam is always not advisable for volatile oil because it can damage the raw material, thereby it can also damage to the natural chemistry of the oil. Temperature of the condensate should always be low in comparison to the still, because if the temperature of condensate is very high, then proper condensation will not occur and we will lose considerable amount of the oil. Firing of the direct field distillation unit should be controlled, as we discussed when we were discussing about the field distillation units, wherein the conventional field distillation units, we are not able to control the fire or the heating of the distillation units, thereby losing considerable amount of the oil in terms of yield and quality. That is why CMAP, they developed certain field distillation units wherein you can control the heat that is being given to the distillation unit, because it has been found that high fire rate will lead to the higher flow rate of the vapors. Higher flow rate of the vapors will lead to the high condensate temperature, which will lead to the improper condensation. One. Second, sometimes high flow rate of vapors also, if you have a very efficient condensation system, it will lead to high condensation rate. That means falling of the water as well as oil droplets, rate of the falling of those droplets will increase, and this will lead to formation of emulsion between oil and water. Again, we will be losing considerable amount of volatile oil. And last but not the least, tank conditions, the distillation tank conditions, that are conditions of the distillation tank that is used for the distillation. It should be non-rusted, and if it is being rusted, then it should be cleaned with the dilute caustic alkali in order to prevent any kind of impurities to enter or to come in contact with the raw material. Perforated grids that are being used in the distillation unit should always be clean. Their pores should not be clogged, because this will hamper or this will disturb the flow rate of the steam through the raw material. Now we move on to another traditional technique, that is enfleurage method, and this technique is largely used to make concretes and absolutes. concretes are nothing but these are the extracts of the plant material that contains volatile oil, and those extracts are prepared with the help of non-aqueous solvents. Whereas absolutes are nothing but the concentrates or pomades are extracted with ethanol, and the ethanol is distilled off. The remaining product is called as an absolute. So enfleurage is largely used to make concretes and absolutes, and it is also used to extract out oil from the delicate plant parts like petals. And we discussed that distillation technique, whether it is hydrodistillation, whether it is water or steam distillation or steam distillation, it should not be used to extract out oil from the delicate parts like petals, because the steam or the heat will damage those petals. So enfleurage is the method of choice to extract out oil from those delicate parts. Since no heat is required in this method is suitable for retaining the original composition of the oil, original color of the oil. And depending upon the temperature at which it is being carried out, it is cold, it can be categorized into cold and hot enfleurage. Now what happens in cold enfleurage? We take a wooden frame having a glass plate fitted in it, and a fatty layer is spread onto that glass plate, and this fatty layer we call it as corp. By and large, it has been seen that one part of tallow and two parts of lard. Now tallow is a fatty animal fat that is obtained from cattle, and lard is the fat that is obtained from the pig. So mixture of one part of tallow and two parts of lard has been found to be most suitable to extract out oil from the petals. So the mixture of this fatty layer is spread onto those glass plates, and petals are carefully placed onto those fatty layer, and this placement of petals onto the fatty layer we call it as enfleurage. Now we allow the petals to remain on that fatty layer for sufficient period of time. That will vary from the plant material to plant material. Say for example, for jasmine 24 hours is sufficient, and there can be flowers for which longer durations are required. So for after appropriate period of time, those petals are carefully removed from the fatty layer. Now this removal of those petals from the fatty layer is known as defleurage, and once defleurage is complete, the again fresh petals are placed onto that fatty layer, and this process of enfleurage and defleurage continues till the fatty layer gets saturated with the volatile oil or the constituents. So here in this image you can clearly see the wooden frames, and there is a fatty layer spread onto the glass plate that is enclosed in the wooden frame, and the petals are placed onto the fatty layer, that is enfleurage is there. And in the lower picture you can see the workers are carefully placing those petals onto the fatty layer, which we call it as enfleurage. Here you can see in the second image the petals are being carefully removed from that fatty layer, and this process, as we discussed, is known as defleurage. Now once the fatty layer is saturated with the volatile oil or the constituents, the petals are removed, which we call it as defleurage. And this saturated fatty material that is obtained, that is rich in volatile oil or the constituent, we call it as pomade. Now this pomade is then extracted with a suitable organic solvent, and the product that is obtained we call it as concrete. So now we have removed the volatile constituent with the help of organic solvent, say for example hexane, and the product obtained is known as concrete. Now this concrete is then further extracted with ethanol, and then the ethanol is distilled off. The product the product that is obtained by distilling of the ethanol, we call it as absolute. Now the success of enfleurage largely depends upon the consistency of the corp or the fatty layer, and as I told you that one part of tallow and two parts of lard has been found to be the most suitable mixture for the enfleurage technique. Corp that is being used should be odorless. It should not have any odor of itself which can interfere with the odor of the volatile oil. The process of cold enfleurage should always be carried out in cool sealers. Sealers are nothing but the rooms having high uh, roof height, which will help in preventing the increase in temperature in that room. Another important factor is the presence of moisture on the petals. It should always be avoided. No moisture should be present on the petals, because the moisture that is present in the petals will cause the fatty layer to become rancid, which will eventually lead to the decrease in the quality of oil, both in terms of quantity as well as its quality. Now we move on to the hot enfleurage, which is also known as maceration. Now in this method, the petals are mixed with the oil or the fat, and they are heated at a temperature of 45 to 60 degrees for 1 hour. Though heating is done in this method, but still the temperature are much below than those temperature which are used during the distillation process. And moreover, the elevated temperature, the material is exposed to the elevated temperature for a very less duration, say for example 1 hour. After that, the melted fat is filtered and the fresh flower petals are added to the melted fat, and the process continues till the fat gets saturated with the volatile oil. Again, once the fat becomes saturated with the volatile oil, it is extracted with alcohol to get absolute. Now this technique has been found more suitable for very delicate flowers which are having very short life. Now if we go back to the cool enfleurage or the cold enfleurage process, the entire harvest can be consumed in the cold enfleurage process, and the entire process will take around 8 to 10 weeks, and it's a very long duration. So therefore, hot enfleurage method is more suitable for those flowers which have very short life after their plucking. And the common example is lily of valley. It has a very short life after the flowers are being plucked, and therefore they are immediately exposed to the hot enfleurage process in order to extract out its volatile oil. Now we move on to the last traditional technique, that is solvent extraction, and this technique is again largely used in perfume industry because it has a major advantage that the oil that is being extracted using solvent extraction retains the natural chemistry of the oil, not only the natural chemistry but the natural color as well as the natural odor of the oil is retained when solvent extraction technique is used. Now this technique involves the utilization of certain non-aqueous volatile solvents to extract out the volatile oil from the plant material. And whatever extraction is done, it is highly uniform because it is being done at a temperature usually 50 degrees. Therefore, the quality of the oil that is obtained by using solvent extraction is very uniform. This is the same what I have told you, that the extracted oils have a more natural odor, and that cannot be compared with the oil that is obtained by the distillation technique. And therefore this method is largely preferred in the perfumery industry and is considered to be a high cost method because organic solvents are involved in it. Now we move on to the modern techniques that are used to extract volatile oil, and the first one is the molecular or short path distillation process. Now it is also known by the name of non-equilibrium process. So as the name indicates, short path distillation, why the name is given? Because the path which is covered by the vapors from the distillation still to the condensation or to the condenser is very short, because the distillation vessel is placed in a very close vicinity to the condenser, and therefore the path that is covered by the vapors of oil as well as water is very short in comparison to the conventional distillation process. And since the path covered by the molecules or the vapors is very short, the extraction time is short, the plant material is exposed to heat for a very shorter period, and therefore the thermal degradation of the oil constituent is very less in comparison to the conventional distillation technique. Now, this technique of extracting volatile oil is largely considered as a purification technique but not an extraction technique. Now, what are the applications of this technique? And this technique is largely used for the separation of vitamins and the fatty material from the plant material. Concretes that are obtained by solid liquid extraction are conventionally converted to absolute by dissolving in alcohol or the aqueous alcohol mixture, and then the alcohol is distilled off using this technique. After that, whatever product is obtained, the waxes are separated by chilling that product at sub-zero temperatures. The fragrance that is retained during the enfleurage method in the fatty material can also be removed from those pomades by using this short path distillation technique. Now, as I told you that the path travelled by the vapors is very short because the distillation still and the condenser are placed very close to each other. This process can be carried out at very low temperatures and at low pressure, which will eventually cause less thermal degradation of the constituents. If the sample is highly viscous, it can be easily handled in this technique. Very low liquid holdup, allowing this technique to be used in application that involve low volume and high value material. If I talk about in simple words, then those plant material which have very low volatile oil content can be extracted by using this technique. Another modern technique is microwave assisted extraction, and this is the most widely used modern technique to extract out volatile oil because various modifications of microwave assisted extractions have been done in order to extract out volatile oil. And the first modification is compressed air microwave distillation, which was proposed by Craviaro in 1989, and perhaps this was the first modern technique that utilizes the microwave for extraction of aromatic plants and spices. In this image you can clearly see the setup of microwave assisted distillation of volatile oil. It contains major three parts. One is the air compressor, which controls the temperature as well as flow of the air into the second part of this unit, that is microwave oven, which contains the reactor part, and third part is the refrigeration system. So the compressor will allow the air at a specific rate and temperature to enter into the vessel where raw material is there, and the vessel is placed in the microwave oven. Microwaves will heat up the feed material along with the heated air, and this heated air will help in carrying the vapors of the oil to the refrigerant system where they are cooled, they are condensed, and the oil is separated from there. This process is fast, energy efficient, and reproducible in terms of quality as well as quantity of the oil. Second modification is microwave hydrodistillation. It is based on the same principle as that of the conventional water or hydrodistillation process, but the only difference is the distillation vessel is heated with the help of microwaves rather than the fire or the electrical heating, and this was developed by Stashenko in 2004. Another modification is in situ microwave assisted extraction. Now here you can see that a microwave antenna is being introduced into the round bottom flask where the raw material along with the water is placed. Now this microwave will help in heating this mixture very fast, and the oil is collected in the collecting tube. Here the RBF is connected with a Clevenger apparatus, you can see in the image. Now this process is very fast because the microwave antenna is directly introduced into the round bottom flask, which will help in very fast heating of the mixture, boiling of the mixture. Major advantage of microwave assisted extraction are, this is a safe and versatile technique because it enhances the distillation rate. It is a quick process. This process is a time and energy efficient, and it can be used at industrial scale also. Another modification is microwave steam distillation, wherein a vessel containing only the raw material is placed in the microwave and steam is generated outside, and the steam is introduced into the vessel. Now the moisture present in the plant material is used as a source, as a solvent for distillation here along with the steam. Again, microwave helps in fastening up the heating process of the raw material along with the steam, and the process becomes faster in comparison to the conventional steam distillation. This was developed by Chimet and his group in 2008. A comparison was made in the microwave steam distillation process as well as the conventional steam distillation process, and it was found that the microwave steam distillation process uses 4 times less time in order to complete the extraction. You can clearly see that it utilizes only 10 minutes to complete the extraction process in comparison to 40 minutes used by the conventional steam distillation process. Power consumption was also approximately reduced by 3 times in case of microwave steam distillation. Carbon emissions were again reduced by 3 to 4 times in comparison to the conventional steam distillation. Water wastage was also reduced by approximately 3 times in comparison to the conventional steam distillation unit, and therefore microwave steam distillation unit is also considered as a green volatile oil extraction technique. Another microwave modification is microwave hydrodiffusion under gravity. Here the condensation system or refrigerant system is placed at a lower level than the distillation still. The raw material is packed into the vessel, that vessel is placed in the microwave. Again, the moisture present in the raw material is used as a solvent. The vessel is heated. The condensation or the refrigerant system has a very mild vacuum because to pull down the vapors, because the warm air is always lighter and it moves towards upward. So in order to move them to in the downward direction, mild vacuum is applied and the vapors are sucked into the refrigerant system where they are condensed and the oil is separated. Then we have vacuum microwave hydrodistillation, and this was developed by Archimex in France, and again the plant material is heated with the help of microwave under vacuum, which fastens up the overall process, reduce the thermal degradation of the volatile constituents, and the oil is separated. Next modern technique is the ultrasound assisted distillation, wherein an ultrasound probe is introduced into the round bottom flask which contains the raw material and water, and ultrasounds help in rupturing of the plant cells containing the volatile oil. Volatile oil is immediately released, the vapors of the oil along with the water are condensed and the oil is separated from the water. Again, this was developed by Chimet and his group, and they use the principle of ultrasound assisted extraction in extracting out volatile oil. Another modern technique is phytosol extraction, which was developed by Phytonics Limited in Manchester, United Kingdom. And this technique was used mostly for the fragrant components of the essential oils and to prepare the phytopharmacological extract, which can easily undergo thermal degradation. Now this process involves the utilization of fluorocarbon solvents. These fluorocarbon solvents are considered to be the new generation fluorocarbon solvents, and the most common solvent under this category is 1,1,2,2 tetrafluoroethane, which is also known as 134A, HFC 134A. This solvent has specific properties. It has a boiling point of -25 degrees Celsius. It is non-flammable, non-toxic, does not deplete ozone layer as like other chlorofluorocarbons. It has a very low vapor pressure of 5.6 bars. Looking into these conditions like boiling point and low vapor pressure, this solvent is considered to be a very poor solvent, but this solvent can be modified and can be made highly selective by addition of co-solvents. Since it has a very low boiling point, extraction is carried out at a very low temperature, therefore no or negligible thermal degradation occurs. This solvent is mostly inert towards phytoconstituents that are present in the oil. Since it has a very low boiling point of -25 degrees Celsius, the solvent residues are very low, and it has been found it is around 20 parts per billion. And this process can be carried out, this process is rather carried out under vacuum, therefore no oxidation of the constituents takes place. Apart from this, we also use supercritical fluid extraction to extract out plant material. Then solid phase micro extraction and head space trapping techniques are generally considered as analytical techniques, used for analytical techniques, because the amount extracted is very less and that can be directly injected into the analytical equipment like GCMS in order to have an analytical profile of the volatile oils. So friends, this was all about the extraction method of volatile oil, starting from the traditional techniques to the latest or the modern techniques that are being used to extract these volatile components. Thank you.